All right, we got a deal. I have one of these guys, but it's from Rode.
Okay. Yeah, the Rode is a little bigger form factor.
It's a little big. You like this? The smaller is better.
Yeah, and I just got these. Actually, I like wired stuff. I just got these because, I hate recharging things. The last thing I need in my life is nothing to recharge.
Yeah.
So I usually use wired. But yeah, I made the switch to DJI recently.
Nice.
Yeah.
I don't have my bag with me. It's in the green room, but I showed you my party trick. I'm like a total gadget guy.
Okay.
And so like when I go to conferences, I always have an anchor battery that has like cords that you can pull out. And people are always just like, oh, you're my best friend. You have, because everybody hates charging.
Right. Yeah, I recently bought the charger I have with me. Is a wall charger, but it's one of the 60-watt ones.
Yeah.
So it'll charge up your phone like in no time. That's a great invention. Whoever did that one.
I have a friend who works in battery technology.
Oh yeah.
And
which they say is much more complex than people realize.
Well, it's like fundamental physics and chemistry. Right. And so he's like, Rob, you don't understand. Any innovation you do in battery technology is an immediate bestseller.
Really?
It's like anything that you do, because it's so hard to make an improvement on batteries, that anything that like meaningfully changes. So like in the last decade, the biggest change I think is that batteries charge a lot faster. And that's a huge, like it really changes what you do with the technology. And of course now we have all these really cool tech. You have iPhone, you have all these other things. The battery charges so much faster, you're much more likely to be able to go and use these things in a bunch of places. But yeah, it's fundamentally hard to improve battery tech because it requires like tons of testing. Like, of course, people want to put batteries on planes. They want to put batteries like next to lava and like high voltage power lines. Right? Like it's very hard. Like that. Like I work on some really cool stuff with some really cool companies, but man, fundamental science is like hard.
Yeah, for sure. Well, obviously, we talked about how long you've been in tech, and me too, and Eric too.
Yeah.
Top three coolest technologies you've worked with, like across the years. I'm curious. I'm curious if it's weighted more towards like the recent AI. Like is the recent stuff really blowing you away, or you're still, you're a man of the classics?
Okay, so here's what blew me away. Our current era of like AI innovation could have only happened if a bunch of weird things just happened to happen at the same time.
Okay, I'm listening.
And so, like clouds, they're amazing. Clouds make networks invisible. But before you had any of these, the hyperscalers, clouds, like networks are so hard to set up. Like you would have like the network person, all of a sudden it's like, network doesn't matter, it's just invisible to you. Storage used to be a really big problem. All of a sudden you have object storage on the cloud. You can like put as many files as you want, as big as you want. Huge change. Similarly, you had, so like, when and there's so many tech like wrapped up in there. We were talking about Databricks earlier, the ability to spin up a whole super-cluster for like a short period of time. When we used to build supercomputers at the university, like that was a like multiple year effort. And I helped startups spin up superclusters like every day.
Right.
I helped startups spin up the amount of compute that was like compared to my research lab. Like you could never imagine it. And like that tech, to have all these computers be able to talk together, you have model parallelism, you have data parallelism, you have like all of these things which on their own are all very difficult problems.
Right.
And then you have to be in this environment where it's like, I love the kind of the San Francisco VC kind of community, because they're just like, well, if it works well at this scale, what if we just put like $100 million into it and just see what happens?
What could go wrong?
You would, when we were helping these companies build their models for the first time, like VCs couldn't even help because they had this prior arrangement with their LPs where basically they didn't have it written up in a way it's like, how do you spend all this money just on infrastructure? Like that's kind of a weird thing. So we would actually have to help startups get paired with family offices because like folks like John Carmack, Eric Schmidt, like these like other famous people, in order to be able to like build some of the first AI models that were out there. It wasn't until a little bit later that VCs figured out it's like, oh, okay, well we can come into this, and then so it's like that exuberance to be able to try this at massive scale. What I think is
Wait a minute, I'm sorry, I want to understand this. So you're saying that before there was a VC model, they had to go to family offices to try to get that funding, really?
To build foundation models, at the very early days, there weren't VCs who could easily just write a check just for compute.
I see what you're saying, okay. I see what you're saying.
And so you basically had to work with more like individuals.
Right.
To be able to do it. It wasn't until later that you could get into being able to work with all the famous VCs. And so what I think is just so interesting, it's like in any other field that you can imagine, nobody's really surprised at innovations like Higgs boson's coming out, and it's like everybody's like, I think we've got the Higgs. I think it's going to come out like it's coming. And I said my family's in medicine. It's just sort of like, all right, we're through year 25 of this trial, right? It's like it takes a really long time.
Right.
None of the people who were working in AI could have expected that all these things that would have had to come together could come together, and then scaling compute was going to be a thing that unlocked that sort of first dimension, that first long pole of the tent. And it works way better than expected.
Sure.
You had to have invisible networks. You had to have unlimited storage. You had to have adjustable kernels that you could go manage on a GPU. You had to have all of these things plus a ton of data, which was the web. You had to have
the TCP/IP protocol.
Right, all of these things to make that happen. There's so much stuff.
Right.
And then like somebody who was just like, yeah, and let's just like take it to 11. Like if it worked for, 100 million parameters, let's just try 5 billion parameters. Right. Let's try 500 billion parameters. And had any one of those things not come together, we would still be decades away.
That's very cool.
And so when I look at these technologies, I like, it's amazing to work for a hyperscaler because these things that were fundamentally hard problems. At the beginning of my career, every bug was a memory bug. Like any time that an engineer came to me with like a problem, it was like, guess what? You're leaking memory here. I haven't fixed the memory bug in ages.
Right.
Eventually, like I had all these like networking bugs. It was like, oh, you're trying to make a request. Well, good luck. It's like there's like 6 ways TCP/IP is going to fail here. Like, it's never going to work. And then it's like, oh, actually, making a request works pretty well now. And then it's like, oh gosh, you're going to run out of machines. But now it's like, actually, you don't even really have to care what the machine is. You can just like go like the whole thing is going to be completely cloud native. You're going to not really have to figure out any of the distribution. That's just going to work for you. And those were every single bug that I was running into. Like my teams, they would always get stuck on these things.
Right.
And so it's just been amazing to watch the progression of technology, where it's sort of like, I was like sure that my ability to write memory safe code was the thing that was going to carry me through my whole career. But that's not really how technology works.
Right.
Like these major things happen, and it takes a while. And like, well, it'll sort of be solved for a while too, but it takes a while before it kind of works its way through all the different dimensions.
Sure.
And then people unlock it in a bunch of interesting ways. And so yeah, I think for me, if you want to know the technologies that I'm actually the most excited about right now, it's this imitation versus experience learning. These learners that we're using right now, they're all imitators,
Right.
you know. But I think if you can simulate environments and you can build a ton of great data, like in the AI era, data is programming. I think we're going to see that people are going to be focusing, their job is going to be like, I'm going to build 100 perfect examples of this thing as the way that you program something, which is totally different than the way we think of software right now. So I'm so excited about the fact that, like, you know, as an AI researcher,
Right.
every AI researcher will tell you, it's like, oh, man, my job is just like, I feel like I'm a janitor. Like, I'm just cleaning up all this bad data, I'm doing this. But now if you could change it so it's like having experts really go and say, like, these are the quintessential examples of this. Here's the way that you want to simulate this. Here's the way that you want to build this. And you can imagine that programming would just feel very different. So I'm really excited about that. I'm really excited about whole systems of agents as you start them being able to work together and understand things like I'm giving a talk on MCP tomorrow, but actually I think that agents being able to run sandboxes where like they write their own code. So you can imagine it's like, hey, on this system, here's your safe sandbox, but I'm not going to tell you what you can and can't do, it's just what's in the sandbox. And then you go figure it out.
Right.
Like, very excited about these things. And then I'm really excited about robotics generally.
That's my next question. Yeah.
Yeah. It's a shame that we are so behind in the United States on robotics. Mm-hmm. One of the pleasures of my job was I got to work on a robotics accelerator. I got to meet a bunch of robotics companies and see what they're doing. And I meet these companies and they're like, how many robots do you have? And they're like, 7. And then you go and you see what China is doing with robotics, and they're making these large-scale industrial robots. They're experts at computer vision. They've got them deployed everywhere. It's just incredible what they've done with robotics. And I just think that American innovation in robotics has been a lot more limited because we're like less hardware stuff centric. We like our virtual stuff. American robotics companies in the virtual space, they're incredible. Like you see people building virtual environments, you see things in Unity. I saw a company last week that can, you go into Unity and you're just like, I'd like to see a dragon, and a dragon appears. And like, I like the dragon to be holding an ice cream cone, and it's holding an ice cream cone.
Wow.
And I'm just like, okay, that is amazing. And so like, we're really good on the software side, but I don't think we just not been as invested on the hardware side. If you look at the number of robots that China has, it's like 80% or more of the world's robots are all built in China. And I'm like, that's like this whole huge space.
Right.
So I'm really excited about that space and see what we'll really do.
Now I got to tell you, I'm going to take a little bit of a, maybe not a contrarian view, but this year you're speaking of something near and dear to my heart.
Yeah.
Because this year I was actually a judge in the CES Innovation Awards.
Yeah.
And I was a judge in the robotics category.
Yeah.
And I was underwhelmed. Now, obviously, I can't speak anything specifics, but I judged 19 entries.
Yep.
You know, and these are all supposed to be, you know, the companies really trying to vie for an award. And I was a little underwhelmed. So, entries from all over the world also, I should say that.
Yep.
But I don't always see that close correlation between the progress in AI and progress in robotics. Yeah, so I'm not sold yet. I'm not sold
Well,
yet.
so it's hard, and I'm glad that it's hard because that makes it really fun, and like all of our engineer friends get to like go and solve really cool things. You know, I was talking to a company and they took a was effectively a Roomba, and they made it be able to print, and they put down all of, you know, when you go to a construction site, there's always on the floor, there's paper to catch all the dust.
Yeah, sure.
And that robot can go and print to the millimeter the entire schematic of the entire thing that you're building, right down to here's the electric, here's everything, perfectly on the floor. So instead of looking at a blueprint, taking out a tape measure like you always did, you will just see the entire project on the surface right next to you. The company is called Dusty Robotics.
Okay.
Imagine how huge a change it is as a person who's going out there to not have to go and bring a tape measure and measure everything in case you make a mistake or anything else. You can literally put your 2x4 where it is, and you can do that right now today. But that worked really easy because like Roomba-ish technology and being able to like put a marker in Roomba was like very retrofittable, very doable in this way. Building new robots, man, it's a lot of work. A lot of things fail. You have little servos that like tries moving a few times and all of a sudden it breaks. Right? Like the real world, it has gnarly edges. Like you have humidity, you have temperature, you have all these things that can change your environment. And so it's not easy to get there. And a lot of the robotics cases that we're like dreaming about, we're excited about, seem far away. But then I think about, NVIDIA had a great demo last year. They were able to show pen spinning virtually, which is like such a funny thing to have, but like, you can then take that environment, that teaching, to actually build a pen spinning robot, which is such like a specific thing. You're able to transpose these things over time. Now, that pen spinning robot may break, and maybe you don't want to build a pen spinning robot. Like, you know, there's these factors. So, from my perspective, there's a lot of stuff that we want robots to do. You want robots to be able to work underwater, lava, high voltage power lines in space. Like you have all these things that we really need to be able to work here, and it's going to take a long time to make those things, and they're hard problems.
Very hard.
It's not as fast as people want because people think, oh, I saw a new humanoid looking robot, Rob, is it going to come and do these things? And I'm like, of course not. Like why? And you know, I saw one of these AI demos, and they had those robots doing all these cool things, and then I'm like, well, what happens if I move something in the scene? They're like, then the whole thing breaks. Please don't move. Please don't move anything. And so, like, robots also are maybe chronically misunderstood. So one example of a problem with a robot is that robots absolutely have to be able to observe their environment to be a robot. So a lot of things are machines that are not robots. So a robot needs to be able to discover the space that it's in and do the right thing. Just like when you're building an AI agent, it needs to be able to respond to lots of different inputs, not just the ones that you put in. And so, no, I don't think that it's easy or fast, but I think it's one of the biggest, most incredible spaces. And there's so many pieces of tech, and a lot of the robots, of course, we as people don't see the greatest robots. A lot of them are industrial cases.
Of course.
I want you to understand that building an NVIDIA GPU involves literally bending physics. These things are moving things within a margin of error that no other thing is built that pristine and that perfect, right? You have to be able to understand things at a absolute atomic level to build an NVIDIA GPU. And those are done with very, very specialized robotic systems, right? That same level of technology is too expensive for most things. You wouldn't want to build it for everything. So I understand the skepticism, but by the same token, it's unlimited potential.
Well, I agree that the potential's there, but to your point, I also think it's going to be a lot longer than people think it is. You know, right or wrong, I have said in some of my previous content that I think that, you know, widespread adoption of robotics, you know, in the home, doing your laundry, you know, whatever fantasy people have, to me, that's measured in decades away, not years away.
Yep.
So I really think that people just give too much credit to what, you know, the dancing robots they see on X or whatever, right?
Yeah, you know, I saw this incredible demo of a robot folding clothes.
Right.
Just absolutely incredible. I want that in my house.
Of course. Yeah.
But then, of course, you see like the cost per scale, everything else. Like there's a lot of reasons why that might not be tomorrow.
Absolutely.
But by the same token, I have a TV that's like the size of my wall.
Right.
And it was not expensive.
Right.
There's these technologies where like eventually the margin comes down so much. It's in that it's everywhere. You know, I don't know kind of anybody who doesn't have a really beautiful TV now, because the cost of those things have basically come down to nothing.
Right.
So some of those problems, like, that's just the way these things they progress.
Sure.
You know, do you have a Roomba?
I don't. But I'll tell you a Roomba story though.
Yeah, tell me.
I was in Dallas. I'm not going to name any names, but I was in Dallas for a business retreat.
Yeah.
I'm sorry, no, Denver. I was in Denver for a business retreat, and I was speaking with a guy there. We were at dinner, and he told me about how he took a bath on an investment for a Roomba type robot.
Yeah.
And I want to say it was for lawns, like a lawn Roomba.
Yeah.
Right.
I've seen those.
Okay.
They're incredibly expensive.
Well, but here's the thing I told him.
Yeah.
I said, you should have called me because I could have told you that investment was a failure.
Yeah.
And the reason I said that is because coming back to CES, I get the CES press releases. I'm on the media list for CES. And every other press release is another Roomba copy.
Yeah.
Like, there are like a couple dozen companies in Asia and other parts of the world that are just basically producing these Roomba copies.
Yeah.
And they'll tell you why they're different. Oh, well, this one has a homing station, and this one, you know, has longer battery or better wheel. But it's all the same product. I mean, it's a much more crowded space than people give it credit for.
Absolutely true. And actually, Roomba is no longer really Roomba, if you haven't heard that. And there's a bunch of other people who are making this tech, and of course, they're saving margin and innovating in other ways. And I was the CTO of a hardware company.
Okay.
We made a device that if you plugged it into your car, called 911. If you got in a crash, it would save you money on your car insurance. It would do all the Internet of Things like set your Nest to the perfect temperature right when you got home. So it would estimate your commute.
Okay.
Just like it's IoT days. Of course, there's so many bubbles. This is the IoT bubble.
Right.
But we built a bunch of things in that space. And there was 1 million copies of our thing. We would actually go and we would look at so-called competitors' websites, and they would have copied verbatim icons that we had made. And I'm like, you literally pixel copied my icon rather than just making your own icon. Yeah. And so it's really hard to be in competitive business. You know, and those products, they were never even close. Like, ours was clearly better, and actually, we liked it because the more competitors, the more that we knew we were building something that felt real.
Really? Okay.
Yeah, I'll tell you a funny thing. When we were selling on the Apple Store by itself, sales weren't that great. and then we were in Best Buy, and sales were still kind of like okay, but then a competitor came in, and then there's like a comparison, and all of a sudden our sales went up because people were like, oh, well, I want the best one. But it's hard, like, now there's a million of these devices and other things, and they don't do like a bunch of the stuff that we did because it kind of comes to some core set of functionality.
Right.
So there's always that economics that I feel like people don't talk about, which is like being first and like being that innovator. Like you end up having to pay a lot of money that your competitors don't have to pay because they get to kind of see all the things that you didn't do.
Right.
So like you have to continue to innovate and continue to invest, and it's hard.
Right. I don't know, maybe this is a silly example, or maybe it's the beer, but are you a fan of Ricky Bobby and the Ricky Bobby movie? Talladega Nights?
I've heard of the movie, but I've not seen it.
Oh, really? You haven't seen any of the Ricky Bobby movies?
I have not.
Oh, I should say, there's only one. I'm talking like it's a series.
Yeah.
There's only one. You haven't seen that one?
I haven't seen it.
Well, because you're reminding me of, because that's one of the premises where this other driver comes in, but he needs Ricky Bobby to challenge him to be that competitor, right?
Yeah.
And so the joke was, that Connie Chung needed Katie Couric to push her, right? So, so you needed a Katie Couric to kind of elevate you in that way.
I like competing as a startup.
Okay.
I actually always enjoyed like being out in the market and kind of like letting these things like actually kind of be in that space. Because also like I'm always very proud of the work that my teams do. And like we try to build a whole culture around it. We try to be like experts at our craft. And so like, if somebody else does something better than us, then it's like we get excited about like learning how to do this other thing, like trying to figure out how to innovate, trying to figure out how to be better. So I've always liked that kind of thing.
Okay.
It's not for everybody. A lot of people I think would rather just like a lot of I feel like enterprise software in particular. Their goal is basically to like find a niche where like no one else is in.
Right.
Right. But I built a lot of consumer products, and so in consumer products you are always going to deal with that. So I think industrial robotics, for example, is a little bit different from consumer robotics. And we as consumers kind of don't know about the industrial robots.
Right.
And so we don't even probably know the best robotics companies because we're not actually seeing them.
I like the way you put that because I've worked in enterprise and I've also worked for startups. And I guess the way I would describe it in the past is that in an enterprise development, you kind of feel like you're just a small cog in the machine, right? You know what cog you turn, but you don't see the bigger picture.
Yeah.
Whereas with startups, like you are the picture, right? And everything is go, 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 go. Just, we don't need code reviews, just push it out, right?
I will tell you, at every single startup, I was the one who implemented code review.
Okay.
This is an actual fact for you, is that, so my dad was, he worked at Carnegie Mellon University.
Okay.
And
great university.
And their school for software engineering.
Sure.
So they did all these studies, and do you know the number one predictor of code quality was what they would call peer review?
Okay.
Basically, if every line of code is reviewed by a person, then it will increase your code quality. So the first thing I implement any place I'm a CTO is I put in peer review, and I teach the value of like, hey, it doesn't matter if you typed it or prompted it, you own it, right? Like that code is your code, and I want you to be proud of that code.
So you mean like the specter of me, the developer, knowing that somebody's going to look at it will push me to be better.
Yeah.
Interesting. Now, okay, I'm going to challenge you a bit on this because I've also led teams, and I'm a big fan of pair programming.
Yeah.
I wasn't at first because I didn't really understand it.
Because it's hard, man. Like you actually have to like practice it.
It is, but it's also very effective, right? So, how would you contrast that with pair programming? Obviously, pair programming, you are sacrificing some resources.
So I like pair programming if you do it in the kind of the original incarnation, which is like one of you has to sit with your hands behind your back while the other person has their hands on the keyboard. And like you actually like sit and you work together. And I actually work with AIs this way a lot. I feel like I'll try to have the AIs write code for me, but like I can't go and edit the code while the AI's editing the code.
Okay.
I have to like explain to it my change, right?
Okay.
I have to say like, no, I don't think you understand what's important to me here. Like, hey, like in this user story, like I need to validate this every single one of these inputs, and it looks like, and I'll like talk to the AI like a programmer,
Okay.
right? Where I'm like going through it. But you really have to have that discipline to not like going like, let me show you, which is really hard because you really want to be like, no, I know how to do this one. Plus, maybe I want to like, I don't know, show off. No, like if you're gonna pair program, you actually have to be willing to have that full conversation.
Right.
And so it's been, but like once all that's done, I still expect for you, after you pair program together, to put the whole thing up for review and have somebody else look at it. And that seems like way too much. But you know what? The cost of mistakes is way more expensive than anybody knows.
For sure.
I would always teach my teams, I'm like, if you catch a mistake yourself, that's 1 point. If it gets caught in like your like unit tests, that's 10 points.
Right.
If it gets caught in code review,
You're done.
100 points. If it gets caught by a customer, 1,000 points, right? You know, if it gets caught by like some crazy analysis, it's probably even more. But like, because I would look at it and I'm like, the cost of a mistake making it all the way to a person, it ripples through everything. It's this huge change. And so I just don't think that people, I think people greatly underestimate the cost of putting out broken code. We might, sorry to take you out of the moment.
Yeah.
I don't know that it's going to get quieter. I think they're going to tear down this whole thing.
Oh, geez. Okay.
Um,
All right. Well, just one last question then.
Yeah.
Earlier, you know, we've been sitting here for a while, and I've enjoyed the conversation. I thank you for your time. You blew my mind.
Yeah.
And I don't want to misquote you here.
Yeah.
But you said business innovations usually tend to do better than tech innovations in the startups you've seen. And you're obviously a tremendous authority on startups.
Yeah.
Because of your position.
Yeah.
So I would love to just have you expand on that, because I thought that was just really, it blew my mind. It really blew my mind.
Of course, as technologists, we all fall in love with the tech first, right? And so like we're really proud of the tech, we invest in the tech, and so we focus on the tech. Like this is our big thing. That's what I was saying.
Yeah.
So as technologists, we really focus on building the best tech that we can, and we think of it as our differentiation. But the reality is that very small business differences can absolutely be the difference between a successful startup and a failing startup. When we look at companies like Intercom that does usage-based pricing, when we look at companies that go through and build who understand who their customers are, we're able to get them pricing that works for them. I think that's what makes the most successful startups, time and time again, are the startups who figure out not just the technology, but where it meets the market.
Right.
So yeah, I think
that's wonderful. I mean, I don't know. As much as it makes sense, it's also just kind of like a profound statement that I think a lot of founders just don't get.
Yeah, I wish for all my engineering friends that just building the best tech would win.
Right.
Because it would feel really egalitarian and great, but I've just seen too many examples where the best company is honestly the one who figures out how to get it in customers' hands.
Well, unfortunately, I think you're right. The noise is going to drown us out here. But thanks so much, Rob.
Yeah, and if you ever want, like, we can always catch up on some
sure.
other. I have a nice home little studio set up too,
Okay.
so we can always do a call or something.
No, I'm pretty sure you just invited me to come over, so
Yeah.
I'm not doing anything later.
Well,
Thanks, Rob.
pleasure, absolutely.
Yeah, thanks a lot.
Yeah.